This is Otishwan here. Welcome to my YouTube channel Subject-o-Phile. I will try to solve all your doubts, be it questions of any subjects like physics, chemistry, mathematics, or biology, or will even post videos on concepts of the topics and chapters from class 11th and 12th as per demand. So this is my first video on this channel which I will be posting today. I hope you all will love it as we explore our way through some interesting and innovative questions, which will surely broaden your mind to think beyond and help you excel in the competitive exams. This is the main purpose of this channel to help you guys. So, enough of talking, let's get right into today's question, which is I hope you can all see it. Let me read it for you guys. The question says, in the given circuit, the maximum potential difference between points A and B is V1. Now, if R1, which is the resistance, if doubled, keeping other parameters unchanged, then maximum potential difference between A and B is V2. Now find V1 by V2. So let me first, after in for every question that I will be posting in the video, I will also mention the concepts in brief concepts which are being used. So if for example, for this question, uh, the concept that is actually being used here, uh, let me write concepts. I hope you can all understand my handwriting, and if it is like not that good, please excuse. I will also voice it over so that nobody misses out. So the concepts which is basically used in this question to solve this question, we would require the fundamental knowledge of alternating current, which is AC. The second thing is a mathematical tool which is related to this chapter only, which we read in class 12 is phasor algebra. And lastly, why this question is so special and it makes it different from the other questions that we generally see in this chapter, alternating currents, is the use of some old mathematics concepts, geometrical concepts, which we might have forgotten, or because it is not being used that much in your competitive exams preparation in class 11th and 12th, which is I am writing geometrical properties. Now, why geometrical properties? You would be wondering that this is a question of circuits, circuit analysis, and why we are talking about geometrical properties. So, as we delve into this question further, we would be seeing why I am saying that it would require geometrical properties to solve. So, let's get into the solution. Solution. Yeah. So, Uh, first, let us define that the peak value of this voltage source, which is the AC source, peak value, say it is V, okay, capital V, and the current, the actual net current which is being provided by this voltage source into the circuit, be it I, the branch currents respectively, I1 and I2. Now, obviously, you know that since this is an AC circuit, we are doing an AC analysis. We can't just simply add this currents. Like it is not such simple addition, okay? So we have to do phasor addition, which is similar to the vector addition. So let me say I equal to I1 plus I2, which is not simple addition. Remember that. Okay. So now, while we generally do the phasor analysis or to break complex circuits, we just find some reference phasors. Now, what do I mean by reference phasors? Like this current, a phasor can be a current phasor or a voltage phasor, right? So, like for suppose we take the branch LR1 branch, okay. Say we take the branch which contains L, the inductance L and the resistance R1. So L R1 branch, which is obviously the points DE only. But I'm not saying D because even the branch which is below it is also D. So let us say it is LR1 branch. Okay. Now this L1 R1 branch, what is the thing which is common to both the resistance and the inductance? That is obviously the current. So our reference phasor actually becomes the current phasor, which is I2. Let us say this is I2, the phasor which is I2. So if this is the phasor, we can definitely say that these are the points D and these are the points, this is the point E, right? So now what we do is see if this is the current phasor I2, then if we have to write the voltage phasors of the inductance L and R1, you all know that the voltage phasor of an inductance always leads its current phasor by 90 degree, right? So the voltage phasor of inductance would be like this, which would be nothing but I2 XL, the inductive reactance of the inductance. And also the reference in the voltage phasor for the resistance would be on the same phase with the current phasor. So there is nothing problem in that. So it would be I2 R1, right? So by simple vector addition, as we do in vector addition, so that somewhere there should be somewhat like this. There should be the net voltage phasor as well. The value of the net voltage phasor will be somewhat like this, which is basically the vector addition of these two vectors, which is the I2XL and the I2R1. Yeah. So this is my net voltage phasor, which is V. All right. So, and also this point is E because we are actually calculating the net voltage between D and E only. And why this is V? Why this value is V? Because the voltage between D and E is the peak value V only, the source voltage, because always the parallel branches will be uh, within the same voltage, no? Like the potential difference between the parallel branches would be same for any branch. So now let us understand what it is this. So okay, so we can write V square equal to I2 square XL square plus I2 square. Although I'm writing all this, but you won't require all this. Why? You would understand why. Okay, so let us make the phasor for the other branch, uh which is the R2 R1 branch, right? R2 R2, sorry, R2 R2 branch, right? R2 R2 branch. So what is the reference phasor here, which is common, the common to both R2 and R2 circuit component, R2 and R2. Obviously, the current phasor I1, it is common to both R2 and R2. So now let us mix again the reference phasor, taking I2 as the reference phasor, I1 as the reference phasor. So if I1 is the reference phasor, we can again write these 2 points is D and this is E. Now, okay, one thing I missed out in this phasor diagram is from D to A, the inductance is here. So the voltage VL, or the voltage in between between the inductance, potential difference between the inductance is VL. So the VL is between D and A, right? So if this point is D, then this point must be A, right? This point must be A. Okay. So so let us say if it is if the width the reference phasor between D and E is I1 in the second branch, which is R2 R2 branch. Uh, from D to B, let us say from D to B, the voltage difference, the potential difference is actually the potential difference between R2, right? So, and we know that the voltage phasor would be in the same phase with the current phasor because it is a resistance. So point B would be somewhere here. Now why I'm doing in the midpoint is because both the resistance of are R2. So the magnitude of the voltage would be equal, right? I2 R2, and even this would be I2 R2. So it is equal. So obviously you can say V again, because this net potential difference, the net potential, which is the net potential, it will be the simple addition because is in the same direction. So like the vector, how we add vectors which are in the same direction, so it's the simple addition. So for this also, I can say it will be a simple addition where it will be I2 R2 plus I2 R2, which makes it 2 I2 R2, right? Now, all this I'm writing, but actually it is of no use. Why? Here comes the magic. What is the magic? Now let us make a the conclusive diagram, conclusive phasor diagram, in the sense that like we want to combine these two diagrams, right? Because obviously this is a single circuit. We have broken this circuit to which actually do analysis, but let us try and visualize something which is common to the entire circuit. Now, what is common to the entire circuit? Anyone can say it is the voltage source V. It is common to both the branches, right? Both are in parallel, so the common phasor which would be for the entire circuit. And so for the entire circuit, sorry, for the entire circuit, let us say from the entire, for the entire circuit, if we have to make a phasor diagram, then the common phasor would be the voltage phasor V, right? Now, what are the points which in between which the voltage phasor is there? Obviously, the point D and E. All those are equipotential points. All those points which you are seeing in the current in the circuit. This is also D, this is also D, this is also D, right? Potential difference would be equal. If this is E, this is E, this is E, then this will also be E, right? Yeah. So, in this entire diagram, what we have to say that from D, like focus on the first phasor diagram, right? If this is D, then we move to A, and as we move into the circuit, right? The way we move into the circuit, if it is D, then we go to A, then we go to E, right? Now we already have B and E in this diagram. So you have to find A. Now what will be A? If this is V, this was some at some angle, say it was some angle phi, right? And this is some angle phi by 2 minus of phi. So let us draw a line at an angle phi, right? And then again draw something like this, because we know those both are perpendicular phasors. The the phasor induct the voltage, the VL, or the voltage, the potential difference between the inductor and the potential difference between R1 would be perpendicular to each other, right? As we saw in the diagram. And this angle would be phi. So if this is phi, it is very clearly evident that this point is basically A. And how could we draw this diagram? Because we know a property of vectors that that we can move the vector, keeping it in the same way we can move a vector anywhere. So like if the vector is here, if the phasor is here, we can transform and move it to here. Okay, so we can complete the triangle. This is how the triangle law of vector addition evolved, right? So this is D and E. From the second phasor diagram, which is this phasor diagram, we can easily see that there would be some point B here again, some point B here. Okay, and clearly, sorry, clearly there would be a phasor like this, which will actually indicate the I2 R2 vectors. Like this would be, okay, now this would be I2 XL, this would be I2 R1, this would be I1 R2, this would be I1 R2. Okay, I did a mistake, right? I did not see. Okay, so this will be all I1. This would be all I1, right? Sorry. I did a mistake. Sorry, guys. Okay, this was I1. This was I1. This was also I1. Now, this is also I1. This is also I1, right? Yeah. Sorry, I had a mistake there. Okay, so this was I1 R2. This was I1 R2. Now, what did the question actually say? The question said that we have to like analyze the potential difference between the points A and B. Initial, whatever the condition is being given in the circuit, according to that, the initial potential or the maximum potential difference between points A and B is V1. Now, for a moment, let's forget the word maximum. Okay. Now, let's try and analyze what can be the maximum, what can be the potential difference between points A and B. And according to this diagram, the potential difference between points A and B, like let us do it in different color. Okay. It will be easy to understand and visualize. Let us choose this. What kind of color? Let us choose this green color. Okay. So, if we see the, I'm sorry. Okay. Right. This is the potential difference like we want, which is let us say which is say we have defined this as V, no? So, okay, let us say this is V A B, right? So this is VAB. So, okay, so what we are doing here now is a very simple thing, trying to understand. Now, let's go back to our class 6th and 7th maths classes, where we were taught a very interesting theorem in circles. If I don't know if you all remember or not, but you should remember because it's a very important theorem in maths, which says that uh, if I draw a circle here, let us say, okay, sorry, that's a bad circle actually. Okay, let us insert some shapes here. That would be great, right? That would be great. A proper circle. Yeah, okay, a proper circle. And also let us draw a line here. So this is, let us say, this is the diameter, okay. And this is the diameter of the circle. And if we draw a triangle, which is perpendicular to each other, we all know there was a theorem which said that any right angle triangle would lie inside the circle, right? Which means any right angle triangle can easily be circumscribed. And uh, the angle or the right angle always lies in a semicircle, lies inside a semicircle, right? So this was some basic theorems that we used to learn back in seventh and eighth grade mathematics, geometry. So we are just going to apply that same concept here. How? Let us see. We can understand that this is a triangle, right? ADAE is a triangle, and also the angle here it is right angle, right? A similar situation. You can find the similarity. So which easily means that that this entire thing can be circumscribed just as the theorem goes, right? This entire thing can be circumscribed. It actually falls inside a circle. And a very interesting, even interesting than what we actually did here is that this line DBE. So we can say DBE, this line is nothing but diameter diameter of this circle whose center whose center is B. Now, clearly, if this is a center B, then we all know that these three lines AB, DB, and B are all the radius of this circle, right? Such a fascinating thing. Therefore, we can say that radius equal to AB, DB, and B. What does this represent? This all represents the magnitude of the voltage the potential difference between these points, which means VAB equal to VBD equal to VBE, which ultimately means it is I1 R2, right? It's I1 R2. So it doesn't matter what is it I1 R2 is. So what matters is we got this important conclusion that this entire thing lies in a semicircle. So let us figure out the next part of this question, which has been asked from us. It says if R1 is doubled, keeping other parameters unchanged, then the maximum potential difference between A and B will be V2. Then find V1 by V2. So So one way to analyze this is we got VAB equal to I1 R2 and there is no term of R1 here. So you can clearly say that we can just simply say that VAB will never change and there is nothing called maximum minimum value here. The value will always be constant because it is the radius of this circle and the circle remains constant. So it is a very big, like a very interesting way to solve this question without doing any kind of extra mathematics, just using a simple geometrical concept and to obviously knowing the concept of phasor algebra. And using that, we can solve such a great question. It does not involve too much physics, not too much mathematics. So, uh, so this is one way to say that okay, V1 equal to V2, right? Like so, I can say that so VAB all has always a constant value, right? Therefore, V1 equal to V2, which basically means V1 by V2 equal to 1. So here we come to our answer, which was asked from us is V1 by V2 equal to 1, which is our answer. But, but, what does this actually mean? That if we double R1, we can easily mathematically say that, okay, it is constant. But what changes will occur here? Some changes will definitely occur, right? We are changing a parameter, R1. So what kind of changes will occur actually? It is very easy, like simple to answer and visualize. Knowing the fact that it is a circle. So let us draw a circle here again. Now let us again draw the phasors, right? And I will not be drawing too much phasors now because it is always already done. So what I will do basically here is I will actually uh, draw the phasor, like draw the line D, E, and somewhere the line A. Now is the center of the circle, which is B, and I will draw a line here. Okay, I'm sorry. I will draw a line. Okay, I'm again so sorry. So I will draw a line which is like this, and I will draw a line which is like this. And obviously, definitely these are two are equal. Now this is the initial condition where everything was all right. Okay, everything was okay. Now one thing you have to understand: if R1 is doubled, like R1 is changed, then the current in this branch I2 will also change, right? Will also change. I2 will also change. Am I right? So if I2 changes, the value of I2 R1 also changes. By how much factor we don't know. We have no idea about it. Like if it is double, then it would be half. It is nothing like that. So okay, we don't know how much it will be changed. So if I2 changes, then I2 XL, which is an inactive reactance, it will also change. The value of VAD will also change, and the value of VAE also change. So let us say, like even if it changes, so understand this, even if it changes, the angle between VL and VR1, which is the potential difference between inductance L and the potential difference between R1, will always be the same. Am I right? Do you all agree with me on this thing? It will be always be right angle, always be same. So if it is always right angle, then it will always follow the mathematical property that we already discussed. So definitely anywhere the point A goes, anywhere, be it anywhere the point goes, sorry, this point A will always lie on this circle, right? This point A will always lie on this circle. So B, it might be like it might be the value of VR1, which is this is the VR1. It might be that the value of VR1 changes, and this is VL. But the entire thing, the point A, which is the main thing, the point A will always lie on this circle is only. So the value VAB, sorry, the value VAB, which is being asked in the question, wherever the point A lies, it will always lie on the circle, right? So wherever the point lies, it will always lie on the circle, and VAB will actually always be the radius of this circle, and and we can say that upon changing any parameters of the LR1 branch, VAB will never change its value, and it will change only change the position of point A on the circumference of the drawn circle, right? So this is the physical significance of uh, changing the parameters. So this is I'm going to hashtag it because this is the takeaway from this question. This is the lesson we have learned from this question. A very beautiful question. So this is the solution. The answer is very simple. It is one. But now let's again just go over the entire thing what we did here. So the question said in the given circuit, the maximum potential difference between the points A and B and C is V1. Now if we double or change the value of R1 to 2R1, then what would be like then the potential difference between A and B will be V2. Then just find the ratio between V1 and V2. So while doing that, we found that by drawing the phasor diagrams, by taking each branch, the first branch, LR1 branch, then taking the R2 branch, we actually came and concluded the entire phasor diagram for the entire circuit, which showed us that this entire triangle which is formed will lie on a circle. Like for any circuit, any AC circuit, when you draw the phasor diagram, when you combine them to find the phasor diagram of the entire circuit, like keeping the reference phasor as the source voltage, you will always find that uh, it would be a shape which can have a circumcircle which can be circumscribed. Like if it is for any other, if it is not a triangle, if it is a quadrilateral, then it will be a cyclic quadrilateral. What I mean to say is this. So if it is a triangle, then it will also have a circumcircle. So just like in this question, so this was the triangle DAE is circumscribed here, and we can easily say that VAB is basically the radius of the circle. So the radius of the circle is equal to the value is equal to I1 R2, which is never going to change by changing any parameters on the LR1 branch, because I1 is not changing, R2 is also not changing, right? So uh, so from there we can say V1 equal to V2. So V1 by V2 equal to 1 because it is the radius of the circle. But this is something which is like which we might have when we are just solving it for the first time. It is very difficult to understand whether it will change or not. Like we don't know actually because in somewhere the student faces problem about thinking this. So the better way to understand it is actually going to the fundamental depth. Like why we are saying that this will always remain constant is because this explanation which we did at the last, that what is actually happening after changing the parameter of the LR1 branch, which is like doubling the value of R1. The only thing that is occurring is the shifting of the point A on the entire circumference of the circle. So basically the locus of point P is of point A upon changing the parameters of the LR1 branch is the given circle. So here, yeah, so you can write another thing that this is locus of A. This is locus of A. The circle is locus of A. Okay, the circle right here is locus of A. The entire A will move on this circle, right? So this is the locus of A. So only A will move on the circle. But if A moves on the circle, does it change the value of VAB? No, because VAB is the radius of the circle. The circle is remaining constant. The radius will also remain constant. Doesn't do anything with the shifting of the position of A. So the radius of the so since VAB is the radius of the circle, so whatever change we do in the parameter, it will not change the value of VAB. So whatever is was the initial value will be the final value. So V1 equal to V2. So the ratio will be V1 by V2. The ratio V1 by V2 will be 1. So this is our answer to this question. I'm sure that I hope that you all understood it and also like this video. Uh, if you have liked this video, then please do subscribe the channel and also share this video with your friends as much as possible, because the knowledge as much as much knowledge will be shared, it will be helpful for the society, right? So and since this is the first video, from the next video onwards, I would be accepting your doubts in which you can post in the comment section also, and I will provide an a ID where to contact me. It might be an email ID or it might be a Telegram channel where you can come and post your doubts, your questions, and the question that I feel that would be like very useful for you all to discuss. I will make a video on it and post it in my channel. And if you don't share any doubts, then I will try to make videos on some of the questions that I've already shortlisted, and I thought that the video should be made on these questions. So I will go ahead with those questions. So thank you. Let's end the video here. I hope you all like this session, like this question, like the solution of this question. And please again try the question at your home alone after seeing the solution, so that you will be able to understand the concept in a very easier way, and try to practice more and more questions on AC, the chapter AC, with the help of phasor algebra, to actually learn and expertise this concept. Okay, so thank you. We will meet again in the next video.